At first, you don't hear them. The desert appears still, timeless, almost frozen in silence. The Sahara stretches beyond the horizon, an ocean of sand under a white-hot sky. Heat shimmers in the distance, bending the air itself. There is no movement, no wind, no warning. Then the ground begins to stir. A column of sand lifts gently from the surface, as if the desert itself has exhaled. It twists, tightens, grows taller. What was invisible seconds ago now stands hundreds of feet high, spinning with quiet determination. A dust devil is born, a living spiral of heat and motion, dancing across one of the most extreme environments on Earth. To ancient travelers, these whirling figures were spirits. To nomads, they were omens. To modern science, they are something even more fascinating, visible proof that the desert is never truly still. The Sahara is not a dead place, it is a machine. Covering more than 3.5 million square miles, the Sahara is the largest hot desert on the planet. It shapes weather systems, influences global climate, and sends billions of tons of dust into the atmosphere every year. That dust fertilizes the Amazon rainforest, feeds plankton in the Atlantic Ocean, and even colors sunsets in Europe. And at the heart of this vast system are forces most people barely notice: dust devils, sand whirlwinds, and massive sandstorms that can darken skis across continents. These phenomena are not random. They are the visible fingerprints of physics at work, born from heat, pressure, and motion on a planetary scale. To understand dust devils, we must begin with heat, the defining force of the Sahara. During the day, desert surfaces can reach temperatures well above 150 degrees Fahrenheit. Sand absorbs solar energy rapidly, heating the air directly above it. This air becomes lighter, less dense, and eager to rise. But rising air does not move straight upward in silence. It twists, pulled by subtle differences in temperature, terrain, and wind. When conditions are just right, that rising air begins to rotate. A dust devil forms when a pocket of hot air near the surface rises rapidly and starts spinning, drawing in loose sand and dust. Unlike tornadoes, dust devils are not connected to storms or clouds. They are powered purely by surface heating. Some are only a few feet tall, flickering briefly before collapsing. Others can grow hundreds, even thousands of feet high, strong enough to flip vehicles, damage structures, and leave scars etched into the desert floor. And the Sahara produces them in staggering numbers. On a single hot afternoon, thousands of dust devils may be forming and dissolving across the desert simultaneously. Most go unseen, but their cumulative effect is enormous. Each one lifts fine particles into the air, feeding the vast atmospheric rivers of dust that define Saharan weather. To early explorers crossing the desert, these spinning columns were terrifying. Accounts from 19th century expeditions describe sudden walls of sand rising from clear skis, men blinded, animals panicking, compasses failing. Without modern forecasts, travelers relied on instinct and experience to survive forces they could not predict or control. The Tuareg and other Saharan nomadic peoples learned to read the desert like a language. Subtle shifts in wind direction, changes in air pressure, the smell of dust on the breeze, these were signals. Dust devils were not merely curiosities. They were warnings, indicators of rising instability in the atmosphere. But dust devils are only the smallest actors in a much larger drama. When regional pressure systems align, when temperature differences stretch across hundreds of miles, the Sahara unleashes something far more powerful: sandstorms. A Saharan sandstorm does not begin suddenly. It builds. Winds accelerate over open terrain, picking up loose particles and hurling them forward. As more sand is lifted, visibility collapses. The sky turns yellow, then orange, then an unnatural red. Day becomes twilight. Breathing becomes difficult. Electronics fail. The desert itself seems to move. Some storms rise more than a mile into the atmosphere. These storms are capable of traveling thousands of miles, crossing the Mediterranean, blanketing southern Europe, and reaching as far as the Americas. Satellites track massive dust plumes stretching across oceans like ghostly continents in the sky. What begins as wind over sand becomes a global event. Scientists now understand that Saharan dust plays a critical role in Earth's climate system. Iron-rich particles fertilize ocean ecosystems. Phosphorus nourishes distant rainforests. Dust affects cloud formation, hurricane intensity, and even global temperatures by reflecting sunlight back into space. The desert is not isolated. It is connected to everything. Yet for all this power, dust devils remain strangely intimate. They move unpredictably, weaving through dunes, villages, roads. Children chase them. Animals spook at their approach. For a brief moment, the invisible forces shaping the planet become visible, twisting columns of air and sand, alive and temporary. On Mars, similar dust devils roam the surface, captured by robotic explorers. The same physics applies there, suggesting that these spinning vortices are not just earthly curiosities, but universal expressions of atmospheric behavior. In studying Saharan dust devils, scientists gain insight into planetary processes far beyond our own world. But here on Earth in the Sahara, they are more than data. They are reminders that even in the harshest environments, motion never stops. Energy flows, air rises, sand remembers the wind. As the sun begins to sink, temperatures drop. Dust devils weaken, unraveling quietly back into the desert. The ground cools, the air settles, silence returns. But it is only temporary. Because tomorrow, when the sun climbs again, the Sahara will awaken once more and the desert will dance. As the day matures in the Sahara, the desert's energy does not fade, it reorganizes. What begins as countless small dust devils dancing independently can, under the right conditions, evolve into something far larger, far more coordinated, and far more dangerous. The invisible boundaries between warm and cool air sharpen. Pressure gradients stretch across hundreds of miles. Winds that were once gentle become purposeful. This is how sandstorms are born. Unlike dust devils, which are local and fleeting, Saharan sandstorms operate on a continental scale. They emerge when strong pressure systems over North Africa collide with extreme surface heating. Air rushes in to equalize the imbalance, accelerating across open desert with nothing to slow it down. Sand grains begin to hop along the surface in a process known as saltation, striking other grains, knocking them loose, and sending them airborne. The storm feeds itself. At ground level, visibility can drop to near zero within minutes. The horizon disappears. Direction becomes meaningless. Even experienced desert travelers can lose their sense of up and down as wind-driven sand scours skin and stings eyes like needles. Breathing becomes labored as fine particles penetrate deep into the lungs. To be caught in a Saharan sandstorm is to experience the desert not as a place, but as a force. Some storms take on a wall-like appearance, massive advancing fronts of dust towering thousands of feet high. These are known as haboobs, particularly common along the southern edges of the Sahara and into the Sahel. From a distance, they resemble solid objects, rolling forward with terrifying inevitability. Entire cities can be swallowed in minutes. For centuries, these storms shaped human movement across North Africa. Trade caravans waited weeks for safe conditions. Routes were chosen not just for distance, but for wind patterns and seasonal stability. Oases were lifelines, memorized and protected with almost spiritual reverence. Losing one could mean losing an entire network of trade. The Sahara did not merely separate civilizations, it filtered them. But sandstorms do not stop at borders. High-altitude winds can lift Saharan dust more than 3 miles into the atmosphere, where it enters powerful jet streams. From there, it travels. Every year, an estimated 100 to 200 million tons of Saharan dust cross the Atlantic Ocean. Satellites track these plumes as they drift westward, sometimes stretching from Africa to the Caribbean in a single, continuous band. When that dust settles, it leaves fingerprints across the planet. In the Amazon rainforest, Saharan dust replenishes phosphorus lost to heavy rainfall. Without it, scientists believe the forest would slowly starve. In the Atlantic Ocean, iron-rich particles stimulate plankton growth, supporting entire marine food chains. In Europe, Saharan dust can tint skis orange and coat cars with a thin, reddish film. Even snowfall in the Alps has been found to carry particles from Africa. The Sahara breathes, and the world inhales. Yet this connection is not without consequences. Fine particulate matter from dust storms can worsen respiratory conditions, trigger asthma, and increase cardiovascular risk. Hospitals in West Africa and Southern Europe see spikes in admissions following major dust events. Air travel is disrupted. Solar energy production can drop as panels are coated in fine grit. Modern technology watches these storms carefully. Satellites, atmospheric models, and ground sensors now allow scientists to forecast major dust events days in advance. But for people living in the desert, the relationship remains personal and immediate. In Saharan communities, sandstorms are not abstract phenomena. They enter homes, bury crops, and erase roads overnight. Entire villages have been relocated as dunes slowly advance, reshaping the landscape inch by inch. The desert is patient. It does not rush. It simply moves. Dust devils play a quieter but equally persistent role in this transformation. Their spinning motion scours the surface, carving faint circular marks known as devil tracks, temporary signatures that vanish with the next wind. Over time, these micro-disturbances help redistribute sand, influencing dune formation and erosion patterns. What appears chaotic is, in fact, ordered by physics. Even the shape of dunes reflects the wind's memory. Crescent-shaped Barkhan dunes form where winds blow consistently from one direction. Star dunes rise where winds shift seasonally, building towering pyramids of sand. Each dune is a record, a frozen moment in an ongoing conversation between air and earth. For scientists, the Sahara is a natural laboratory. Studying its dust storms helps refine climate models, improve weather prediction, and understand how aerosols influence cloud formation and rainfall. Dust can cool the planet by reflecting sunlight, but it can also warm the atmosphere by absorbing heat. The balance is delicate, and it matters. Climate change is already altering this balance. Rising global temperatures may intensify Saharan dust activity by expanding dry regions and strengthening certain wind systems. At the same time, changes in vegetation cover and rainfall could stabilize some areas while destabilizing others. The desert is not simply expanding or shrinking, it is rearranging itself. This has profound implications for the Sahel, where millions depend on predictable seasons. Too much dust can suppress rainfall. Too little can disrupt nutrient cycles. What happens in the Sahara does not stay in the Sahara. Even space agencies pay attention. When NASA's Mars rovers observed towering dust devils sweeping across the Martian surface, scientists immediately recognized the familiar physics. The same equations that describe Saharan vortices apply on another planet entirely. In this way, the Sahara becomes a bridge, linking Earth science to planetary science, grounded reality to cosmic perspective. And still, for all this scale, there is something deeply human about watching a dust devil form. A child stands barefoot in the sand, shielding their eyes. The column spins closer, humming softly, then veers away. For a brief moment, the desert reveals one of its hidden mechanisms, not through equations or satellites, but through movement you can see and feel. As the afternoon wanes, winds often strengthen again, signaling the possibility of something larger. A distant haze thickens. The sky loses clarity. Animals grow restless. Those who know the desert begin to prepare. Because the Sahara never announces its intentions. And in the final part of this journey, we will step fully into the heart of the storm. exploring the future of Saharan dust in a changing climate, its role in human survival and adaptation, and why these swirling forces of sand may hold lessons not just about deserts, but about balance itself. When the storm finally arrives, it does not rush. It advances with patience, like something ancient and certain of its power. The horizon fades first, swallowed by a thickening veil of dust. Colors drain from the world. Sound changes. Wind no longer whispers, it presses, steadily, insistently, carrying millions of years of erosion in every breath. This is the Sahara in its most honest form. Sandstorms remind us that deserts are not empty. They are active systems, constantly reshaping themselves and everything around them. Every grain of sand carried aloft has a history, once part of a mountain, a riverbed, a seabed long vanished. Over geological time, the Sahara has been ocean, forest, grassland. Its dust carries that memory forward, scattering fragments of ancient worlds across modern skies. For people who live within the desert's reach, survival has always depended on respect for these forces. Nomadic cultures adapted not by resisting the desert but by moving with it. Camps were temporary. Possessions were light. Knowledge was heavy, stored in stories, roots, stars, and wind patterns memorized over generations. Modern infrastructure struggles where flexibility once thrived. Roads vanish overnight beneath drifting dunes. Solar farms must be cleaned constantly to remain functional. Airports shut down as visibility collapses. Even satellites, orbiting far above the planet, can see Saharan dust altering weather systems thousands of miles away. The desert no longer feels distant, it feels connected. In recent years, scientists have begun to understand just how deeply Saharan dust influences life on Earth. Hurricanes in the Atlantic are partially regulated by dust layers that suppress storm formation. Coral reefs in the Caribbean suffer when excessive dust blocks sunlight or introduces harmful microorganisms. At the same time, ecosystems depend on this same dust for nutrients. The balance is fragile, and small changes can ripple outward in unpredictable ways. Climate change adds another layer of uncertainty. As temperatures rise, models suggest that extreme dust events may become more frequent or more intense in certain regions. Longer droughts loosen soil. Stronger wind patterns lift it higher and carry it farther. Human land use, deforestation, overgrazing, poorly managed agriculture can amplify these effects. The line between natural process and human influence blurs. Dust devils, once seen as harmless curiosities, now offer valuable clues. Their frequency, size, and distribution reflect surface temperature changes. Studying them helps scientists track how heat moves through the atmosphere at the smallest scales. In this way, even the tiniest whirl of sand becomes data, a message written in motion. On Mars, dust devils clean solar panels on robotic explorers, extending missions by chance and coincidence. On Earth, they remind us that nature does not distinguish between beauty and danger. It simply operates. As night falls over the Sahara, winds finally ease. The storm passes, leaving behind a changed landscape. Dunes have shifted, tracks are erased. The desert looks untouched and entirely new. This is the paradox of sand. It destroys evidence but preserves process. Nothing here is permanent except change. Standing in the quiet after a storm, one can understand why ancient cultures attributed spirit and intention to the wind. When forces are this vast, this precise, this recurring, they feel purposeful. But the truth is even more compelling. The Sahara does not act with intention. It acts with balance, responding to energy, pressure, and motion in ways that have shaped the planet for millions of years. And humanity is part of that system, not separate from it. Every breath carries particles from distant places. Every climate decision alters wind patterns somewhere else. The dust rising from the Sahara today may fall on a rainforest tomorrow, or drift across an ocean, or color a sunset half a world away. The desert speaks, not in words but in movement. Dust devils spin and vanish. Sandstorms rise and pass. The Sahara endures, not as a static monument, but as a living engine of Earth's atmosphere. In watching its winds, we learn humility. In studying its storms, we learn connection. And in respecting its power, we glimpse the delicate balance that sustains life itself. This is not a story about sand. It is a story about motion, about energy, about a planet that is always in conversation with itself. And somewhere, under the relentless sun, the ground begins to warm again. The air starts to rise, and the desert prepares to dance.